At the end of this video, you should be able to define empirical formula and explain how the term applies to ionic and molecular compounds, determine an empirical formula from either percentage or mass composition, explain the relationship between empirical formula and molecular formula of a given compound, and determine a molecular formula from an empirical formula. Chapter 7, Section 4, Determining Chemical Formulas. When a new substance is synthesized or is discovered, it is analyzed quantitatively to reveal its percentage composition. From this data, the empirical formula is then determined. The empirical formula consists of the symbols of the elements combined in a compound with subscripts showing the smallest whole number ratio of moles of the different atoms in that compound. For an ionic compound, the formula unit is usually the compound's empirical formula. For a molecular compound, however, the empirical formula does not necessarily indicate the actual number of atoms present in each molecule. For example, the empirical formula of the gas diborane is BH3, but the molecular formula is B2H6. In this case, the number of atoms given by the molecular formula corresponds to the empirical ratio multiplied by 2. Calculation of empirical formulas. To determine a compound's empirical formula from its percentage composition, begin by converting percentage composition to a mass composition. Assume that you have a 100.0 gram sample of the compound. Then calculate the amount of each element in the sample. For example, the percentage composition of diborane is 78.1% boron and 21.9% hydrogen. Therefore, 100.0 grams of diborane contains 78.1 grams of boron and 21.9 grams of hydrogen. Next, the mass composition of each element is converted to a composition in moles by dividing by the appropriate molar mass. These values give a mole ratio of 7.22 moles of borane to 21.7 moles of hydrogen. However, this is not a ratio of smallest whole numbers. To find such a ratio, divide each number of moles by the smallest number in the existing ratio. Because of rounding or experimental error, a compound's mole ratio sometimes consists of numbers close to whole numbers instead of exact whole numbers. In this case, the differences from whole numbers may be ignored and the nearest whole number taken. Thus, diborane contains atoms in a ratio of 1 boron to 3 hydrogen. The compound's empirical formula is BH3. Sometimes mass composition is known instead of percentage composition. To determine the empirical formula in this case, convert mass composition to composition in moles, then calculate the smallest whole number ratio of moles of the atoms. This process is shown in sample problem 7-13 on page 231 of your text. Calculation of molecular formulas. Remember that the empirical formula contains the smallest possible whole numbers that describe the atomic ratio. The molecular formula is the actual formula of the molecular compound. An empirical formula may or may not be a correct molecular formula. For example, diborane's empirical formula is BH3. Any multiple of BH3, such as B2H6, B3H9, B4H12, and so on, represents the same ratio of boron atoms to hydrogen atoms. The molecular compounds ethene, C2H4, and cyclopropane, C3H6, also share an identical atomic ratio, 2 hydrogen to 1 carbon. Yet they are very different substances. How is the correct formula of a molecular compound found from an empirical formula? The relationship between a compound's empirical formula and its molecular formula can be written as follows. X multiplied by the empirical formula is equal to the molecular formula. The number represented by X is a whole number multiple, indicating the factor by which the subscripts in the empirical formula must be multiplied to obtain the molecular formula. Note, the value of X is sometimes 1. the formula masses have a similar relationship. X multiplied by the empirical formula mass is equal to the molecular formula mass. To determine the molecular formula of a compound, you must know the compound's formula mass. For example, experimentation shows the formula mass of diborane to be 27.67 AMU. The formula mass of the empirical formula, BH3, is 13.84. Dividing the experimental formula mass by the empirical formula mass gives the value of X for diborane, which is 2. The molecular formula for diborane is therefore B2H6. Recall that a compound's molecular formula mass is numerically equal to its molar mass. So a compound's molecular formula can also be found given the compound's empirical formula and its molar mass.
The empirical formula of a compound is the simplest formula for that compound. The molecular formula, on the other hand, shows you exactly how many of each type of atom is in the molecule. The molecular formula is always a multiple of the empirical formula. In some cases, two compounds can have the same empirical formula but different molecular formulas. For example, formaldehyde and glucose have the empirical formula CH2O. But glucose has 6 times as many carbons, hydrogens, and oxygens as formaldehyde. In this case, more does not mean more of the same. Formaldehyde is used in preserving specimens and embalming bodies. Glucose, on the other hand, is a type of sugar.
At this point, you should be able to define empirical formula and explain how the term applies to ionic and molecular compounds, determine an empirical formula from either a percentage or mass composition, explain the relationship between the empirical formula and the molecular formula of a given compound, and determine a molecular formula from an empirical formula.